Hey everyone, we'll get started. Thank you guys for joining today. I'm Andy Lin, VP of Strategy and Innovation at Mark III, and your host for today's session. Welcome to Getting Started with Containers and AI, the basics. This is the fifth session in our AI education series for Clemson University and MUSC, and more specifically the Clemson MUSC AI Hub. Today's session is all around containers, the ecosystem around containers, and really how to get started or get going around the software stack that powers AI and machine learning. For those of you who have been part of our first four sessions in this series, as you've noticed, most of them have been around data science topics, anything from machine learning to making predictions, deep learning to computer vision, to sort of the art of acquiring and normalizing data sets. But today's session is all around really containerization, around Docker, around Kubernetes, and some of the tooling in the ecosystem, really to where the rubber meets the road on how to get started and get past all the issues with like libraries and prereqs and all that stuff that in the past have really sort of slowed the progress of getting your frameworks up and building models. And now we're in a completely different place where things are much easier and smoother if you sort of follow the ecosystem best practices. But if you have questions or are interested in any of the previous sessions, we do have a web page. Those of you to sign up where you can view some of the first four sessions as well. Definitely recommend you check it out. If you have questions, feel free to ask us as well. And I'll put that in the chat a little bit later on some of these different previous sessions that you can kind of take a look at. We did just post a new session for 2 weeks out. It's all about NVIDIA Clara, which is NVIDIA's healthcare focused framework. I know this is obviously Clemson MUSC AI Hub, so I definitely recommend you check that out. Clara has gotten a lot of traction in the marketplace. There are a lot of frameworks within that ecosystem that do all kinds of different things that are healthcare focused that I think you'll find really interesting. So feel free to hit the webpage and check it out and share it and socialize it as well. I think that'll be a great session next week. And as always, we operate 100% off requests. If you guys have any thoughts, any ideas, just feel free to email myself, Melissa, any of us on here, any of the awesome folks at the AI Hub directly as well, who we work with on just some ideas. We actually had built the data set in the Introduction to Datasets course I think about 4 weeks ago, based directly off some of the requests that you guys had that we use sort of in a public health use case, but could also be used in some others as well. So like I said, could definitely be useful and practical. But again, we'll be next Wednesday at 4 p.m. It's a little quick overview of us. We're a NVIDIA NPM Elite partner. We're also a NetApp partner as well. So really covering the full stack all the way down to the data and GPU compute as far as within the ML and DL ecosystem. This education series is a big part of what we're doing. But it's not the only component. There are a lot of other things and a lot of other ways that we can collaborate, engage with y'all's team. So feel free to reach out if you guys have questions, workshops, hackathons. There's all kinds of different ways as well. So just feel free to reach out if you guys have any questions. So with that, what I'm going to do is I'm going to actually introduce a couple speakers that'll be leading your session today. Most of you guys are familiar with Michaela Buchanan on our team. She led the first four sessions from a data science perspective. Today, our guest speakers are going to be focused more on the DevOps and MLOps side of things. So we've got Seth Forgosh from NetApp, who's going to lead the first 30 minutes, all about an introduction to containers, and then a little bit about the data side around how do you protect and clone Jupyter notebooks for reproducibility, like all kinds of like data things that may or may not be an issue now, but as you get going, but definitely will be a thing as you further your research and your data science. You're going to want to understand versioning and all these things on the data set side. And then next we'll have Zoe Ryan as well from NVIDIA, and she's going to actually take you through NVIDIA's NGC catalog, which is a catalog of all kinds of images, Helm charts. Like it really is the gold standard out there for if you want pre-tested, pre-validated ways to spin up TensorFlow, spin up PyTorch, really anything you need in the ecosystem. This is the way to go and the way to maximize your success just from our perspective. So with that, I wanted to go ahead and turn it over to Seth. Seth?
All right.
It's all yours.
Thanks so much. I'm going to go ahead and share out this PowerPoint, and we'll get you started on our discussion. Can everybody see this okay? I never know whether Zoom is good or bad on the large screen.
It looks great, Seth.
All right, fantastic. So my name's Seth Forgosh. I'm a solutions architect with NetApp. I am not a data scientist by any stretch of the imagination. I will leave all of that to Zoe. But I do focus on cloud native storage for NetApp, and I'm going to spend about 20, 30 minutes talking to you about Kubernetes, containers, what they are, why you might want containers versus bare metal, and some of the challenges that have sprung up around Kubernetes in particular, because Kubernetes really is how MLOps really runs. So, let's start at the very basics. What are containers? Why should I care about containers? For quite some time, we've been virtualizing our systems. We've built up platforms to support large numbers of virtual machines to get density out of our compute infrastructure. But virtual machines are fairly heavyweight. You've got to first virtualize the entire x86 stack, and then you have to load an operating system on top of that virtual machine, and then you're responsible for maintaining that virtual machine through upgrades and releases, and lots of cruft builds up within those virtual machines over time. So they tend to gain this density that causes things to slow down. Containers, on the other hand, don't involve a hypervisor. A container is really just an app and its dependencies, and all the containers share a slice of the host's kernel. So they're very lightweight. They're isolated processes in the user space on the host OS. And this allows them to spin up much more rapidly, have a lighter weight about them, and allows for things like running through different iterations and not having to go through the whole process of maintaining the entire operating system. So while containers make everything better, that it's a bit of a tongue-in-cheek, they do introduce the ability to introduce portability and agility. You can spin a container up on your laptop in Docker, and Docker is just one of many container engines. But you can spin that up on your laptop, do some prototyping, move that over to a Kubernetes cluster running in the data center, maybe attached to a DGX, move it up into the public cloud, and move it back and forth, and really be portable with those environments. Because they're so lightweight, because they spin up quickly, because they're portable, and they're not tied to the exact operating system that you've installed. They are more or less consistent across those deployments. And again, less overhead means that you can use more of the processing power of your hosts to run your workflows. And really, these are kind of the drivers around container adoption. And containers have really taken off. They're not really a new thing. There's been containers since the mainframe, and it just means that we're at a point now where you don't have to be an SRE. You don't have to be superhuman to be able to spin up a container. A couple years ago, a Google engineer did a demonstration that really brought the point home. He spent 30 to 45 minutes typing in code and commands into a Linux box to spin up a single container. He then repeated the process with Docker run, right? So Docker made it accessible to mere humans to spin up containers. But that also means that we're spinning up lots of containers. We're spinning these things up at an incredible rate. And that's where Kubernetes came into the picture. Kubernetes was introduced as a way to manage lots of containers to build applications out of these microservices and be able to manage that infrastructure across a wide range of compute platforms. So this is kind of a snapshot of the state of cloud native today, and some of the applications that are being used out in the field, in the wild. You can see there is a pretty wide range of use cases. There's relational databases, there's data warehouses, there's, of course, machine learning and AI, and they're at different stages of deployment. Quite a few customers are and folks are out in the field are running machine learning and AI in the cloud, right? And the reason for running things in the public cloud specifically is that it removes a barrier to entry. You don't have to stand up a Kubernetes cluster in your data center to be able to do your templating and do your development work. You can do that very quickly, very rapidly, without an investment in infrastructure in the public cloud. And then you can bring that back on-prem to do your heavy lifting work, because the public cloud, is always going to be your most expensive data center. So things that you're doing trial and error and iterating through processes, that's a perfect place to use the public cloud. Once you've established your models, bring them back on-prem and feed your NVIDIA GPUs to do your heavy lifting. And that brings in some of the challenges around Kubernetes. So where does NetApp fit in? Whenever I talk about Kubernetes, and I like to start with this slide, because NetApp might not be the most familiar name to you around Kubernetes or cloud native, for instance. But we have a long history in the container space. Back in 2013, we started working with Docker when our customers came to us and said, we're experimenting with these things called containers. We'd like to be able to have some storage. We then joined the CNCF in 2014. So we are a platinum sponsor of the Cloud Native Foundation, which is the governing body for Kubernetes. And we hold board elected representation within the CNCF. We help as a member of the community by driving forward the state of the art, particularly around storage, because that is our area of expertise in Kubernetes. For instance, the iSCSI stack, block storage, was in a state where it wasn't a matter of if you would lose data, it was a matter of when. So NetApp took it upon itself to rewrite the storage stack and contribute that back to the upstream release as a member. This has value to the entire community, not just NetApp, but we are an active member of that community, driving forward the state of the art. So at the very tail end of 2015, we introduced a bit of open source code called the NetApp Docker Volume plugin. And this was really a watershed event for us. We released the NetApp Docker Volume plugin as a way to natively, within the Docker infrastructure, to dynamically provision a Docker volume without having to have any knowledge of the storage. A Docker user could issue the Docker volume create command, specifying the NetApp Docker Volume plugin as the driver, and that piece of open source code would then make the API calls to the storage to dynamically provision the storage that Docker user wanted. What this really meant was that somebody using Docker could now dynamically provision their own storage without having to first talk to a storage administrator or some infrastructure team to get that storage 3, 4, 5 weeks later. This gave them a cloud-like experience on-prem, and did so in their native toolset. We then followed on from Docker Volume Plugin to release Trident. And Trident represents the first external provisioner for Kubernetes. I'm going to talk a little bit about some of the challenges of provisioning storage for Kubernetes, because it's actually a bit more complicated than just with Docker. And that single provisioner, Trident, now consumes Docker as well. So single tool set to work with both Docker and Kubernetes. And we are agnostic as to the distributions. So whether it's OpenShift or it's upstream Kubernetes or Rancher or Mirantis Kubernetes engine, we really don't care. We work with them all because we help define the standard for how storage is connected to Kubernetes and to pods. The other nice thing about Trident is, from a consumer's perspective and from a storage team's perspective, right? Because there's still a lot of operations that has to happen behind the scenes to make this all a reality. Magic doesn't just happen in the cloud. Trident supports all of NetApp's primary storage. So whether you're on-prem with our ONTAP operating system, or you're in the public cloud with Cloud Volume Services on GCP, or Azure NetApp Files, a first-party service on Azure, or FSx ONTAP in AWS, again, a first-party service directly from AWS, Trident supports them all. And that means that you only have to know how to manage your storage once. And then finally, we introduced in 2020 a new set of tools, and Trident now falls under that umbrella, called Astra. And Astra is about taking that last mile and providing the capability to back up, to recover, to migrate workloads in Kubernetes, something that the Kubernetes community still hasn't really addressed. So let's talk about persistent storage in Kubernetes. The fact of the matter is, stateful sets and PVC usage is growing in Kubernetes. And this kind of takes a look back all the way back to the February 20 through June 2021. The reality of Kubernetes is that it started with this idea that, and containers with Docker, that everything would be ephemeral, that there would be no statefulness. The reality is, containers are ephemeral, the data is persistent. And there are very, very few truly, completely ephemeral applications. But that introduces some challenges. And if you look at the upper right-hand chart, one of the leading challenges in containers is storage. And the reason that it's a challenge, especially in Kubernetes, is that Kubernetes is designed to allow pods or the containers to move between nodes in the Kubernetes cluster. However, early on, the only way to give persistent storage was by consuming the disk in the actual physical nodes. What that meant was that when a pod moved, when Kubernetes rescheduled a pod, either because it crashed or it needed to rebalance workload, the storage couldn't move with the pod, which meant that Kubernetes would fail. So NetApp worked with the community to introduce the idea of external provisioning, right? And that's what Trident brings to the table. This idea of dynamically externally provisioned storage that can move with your pods as they migrate around your Kubernetes cluster. And this comes together with two major personalities or personas, right? We've got our Kubernetes consumer, our data scientists. They need simplified access to storage. They need to be able to abstract away all the complexities of storage, and with the native tools, without modifying their manifests, without modifying their tool sets, to be able to dynamically provision storage when they need it, rather than again, making a ServiceNow request that gets fulfilled in several weeks. For our storage administration team, for the operations team, they need to be able to provide that capability, but to do it safely, to control and monitor and be able to step away from their day-to-day operations of creating volumes and LUNs, which they've been doing for 30 years, and they're really good at it, but there's not a lot of value to the university or to the industry to creating another LUN or another volume. Their time instead is spent monitoring and maintaining the underlying infrastructure that makes all the magic happen, and ensuring that there's performance and capacity available when the data scientists need it. So as I said, Trident now falls under the Astra umbrella. So we got a little bit of a name change to Astra Trident, and it is the world's first and most mature CSI dynamic provisioner. Now, CSI is a working group and a set of APIs within Kubernetes that NetApp helped develop with the community that describes how do you connect, how does Kubernetes connect storage to pods. But Trident's really kind of unique in the industry. It is an open source project. You can go to GitHub and take a look at it and see the code. But it is maintained and supported by NetApp, which means that if there is some sort of problem, you can open up a support case, or more likely your operations team can open up a support case and get support from NetApp. Whereas other vendors in the industry who have released CSI orchestrators have done so as community support. It's designed specifically for Kubernetes and NetApp. We go beyond what the CSI spec defines and introduce additional capabilities and allow for, through native Kubernetes infrastructure, through the storage class mechanism, to offer differentiated storage capabilities to the end users, to the data scientists. So it makes for a very easy consumption of the storage, which is, again, cross-platform, both in terms of the storage platforms as well as the distributions of Kubernetes. So I mentioned CSI, and I apologize for the three-letter acronym up front. CSI stands for Container Storage Interface. And again, NetApp was a major contributor to defining CSI. As a member of the community, we wanted to be able to push forward a state-of-the-art set of APIs that allowed for Kubernetes to connect storage in a rational way, so that we didn't have to, every vendor didn't have to write their own set of tools and require our customers to go ahead and install different methodologies that might conflict. So Trident, of course, is a CSI provisioner, and it's a superset of functionality. In addition to just dynamically provisioning storage, which is pretty remarkable on its own, it introduces the ability to do things like cloning data sets. And those are zero cost copies, meaning we're not consuming twice the space. We're not pulling the data down across the network and then writing it back out to disk. We're providing instantaneous clones that consume no additional disk space, which means that you can take a data set that you're going to work on and clone that off multiple times through different iterations and modify it as you see fit. And this ties into some of our additional code. So this just kind of wraps up the concept of Kubernetes, right? Kubernetes is a cloud operating system. It's the cloud operating system for next-gen compute. And cloud is one of those amorphous terms, right? Whether it's on-prem or it's in the public cloud, it's cloud. And most universities, most customers that I talk to, and I cover all of North America, almost to a one, customers are on a journey to a multi-cloud environment, a hybrid cloud environment where they have both on-prem cloud and public cloud, and they use those for the appropriate use cases. Kubernetes works because it allows you to manage containers at scale, right? You can run hundreds or thousands of applications and know that if there's a failure in the infrastructure, Kubernetes will move your application dynamically within that Kubernetes cluster, and really just makes your life very easy to run. But knowing that storage was one of the top 3 challenges with Kubernetes, persistent storage requirements for stateful applications were solved with Trident. So from a NetApp perspective, we solve that problem and give you the ability to dynamically move workloads back and forth between your private and your public clouds. Now, this is the part where I pretend I really understand DataOps. But NetApp it works with NVIDIA, and we offer a storage solution called ONTAP AI, which is NetApp ONTAP storage, along with NVIDIA GGX A100s. And in addition to that, we offer what we call the NetApp DataOps Toolkit. So the DataOps Toolkit is a Python library, and its goal is to make it really easy for developers and data scientists and data engineers like yourselves to perform data management tasks without having to really know the underlying nuts and bolts of storage. Tasks like provisioning a new data volume or development workspace, or cloning a development workspace instantaneously to stand up a new trial. This Python library has a library of functions that can run. You can run from a command line, or you can use that library of functions within a Python program or within a Jupyter notebook. And this allows you to build that workflow to be able to do the steps to provision out these environments very quickly, again, and in a very space efficient way. The toolkit enhances the AI control plane. Our control plane is a full stack AI data and experiment management reference architecture that we developed with the help of NVIDIA. It makes it easier to invoke these data management tasks and allows the data scientists who are working with Jupyter notebooks to easily execute storage tasks within their workflows. I do have those links to more information about the DataOps Toolkit, as well as an overview of ONTAP AI. And we will be sharing these slides with you so that you can follow those links. Yeah, okay. I just saw there were a couple questions. So yes, we definitely will be sharing these slides. All right. So what does this actually mean for the data scientists? Well, this is the kind of acceleration of your workflow that we're talking about. If we took a 10 terabyte data set, it takes 2 seconds to clone that data set versus up to 17 hours. And because we're using the space-efficient cloning, the zero copy cloning, we can create 10 copies of that data set, and initially they consume no additional disk space. Only the 4K blocks, the very minute changes that get made to that data set actually consume additional capacity. So this allows us to rapidly prototype, fail back, leveraging snapshot capabilities through the DataOps toolkit, recover back if we make a mistake, and really means that we can keep the NVIDIA GPUs fed, we can keep you productive, driving innovation. Hopefully this was helpful and gave you kind of a very high level view of our involvement in Kubernetes and DataOps. I encourage you, I've got peers of mine who specialize in AI ML, and we'd love to be able to talk to you further about your efforts and how NetApp can help you achieve your goals. Are there any questions?
And if you guys have questions, and this is Andy again, feel free to ask it also on the, I should have mentioned at the beginning, using the Q&A box at the bottom. We're happy to address some. There's been some questions like Seth pointed out around sharing some of the slides and recordings. We definitely will after the session. But yeah, Seth, very much appreciate your talk. And I can tell you the DataOps toolkit's incredible. We've done some work with it specifically around Jupyter notebooks and that process of sort of data set versioning and cloning the environments. It's a really, really important thing, especially if you're training a lot of models and you're just trying to figure out what's the delta between this model and this model. It's stuff, that type of thing, like really, really comes in handy. So appreciate it, Seth.
Thanks so much.
Okay, next we have Zoe Ryan with NVIDIA, and she's a solutions architect over there, and she is going to spend about 25 minutes talking to you guys specifically about workflows, specifically around NVIDIA's NGC catalog. Definitely recommend you guys bookmark it and check it out. She's going to talk to you a little bit about why it's so powerful, regardless if you're getting started with AI, machine learning, deep learning, or if you're somewhat advanced and trying to deploy Helm charts around Kubernetes. It does a lot of different things that are really, really incredible, save you lots of time. So Zoe, it's all yours.
Awesome, thank you. Hopefully you guys are all seeing my screen all right. Yeah, thanks for that great introduction and also going over the containers. I think that's a really nice setting the stage point for the content that we're going to cover here about NGC. So for those of you who haven't had any experience with NGC, might be a lot of content for a short amount of time, but I really can't emphasize enough how powerful it can be to just get onto NGC on your own computer and just start playing around with some of the tools we have available. I'm going to just point you in a bunch of different directions of all the cool things you can do. And then I really hope you take the time after this to go through and actually explore on your own. So like it was mentioned, my name is Zoe Ryan, and I'm a solutions architect at NVIDIA, someone who utilizes NGC quite a bit, and I'm really excited to share with you guys today. So let's see. All right. So at a high level, NGC, which I know we always are using these three-letter acronyms, in this case is NVIDIA GPU Cloud. The NGC catalog at a high level really offers you a state-of-the-art GPU optimized software. So if you're a person who has no GPU experience so far, that is also totally a fine place to be for getting started with NGC. I actually think this is the best place to get started with GPU accelerated software because it really can hold your hand and walk you through some really state-of-the-art and finely tuned applications. So here we have kind of 5 categories of things that you can find within the NGC catalog. And the catalog is where the website will drop you when you actually go to NVIDIA's NGC website. Starting on the left here, I know we had some mention of this earlier. We have our AI frameworks available as containers inside of NGC. And personally, as a person who came to NVIDIA, not as a data scientist, but more focused on the HPC side, I think that these containers within NGC for PyTorch and TensorFlow are the easiest way to get up and started with your own custom development for either framework. It automatically takes care of the dependencies you'll need, gives you kind of a nice sandbox area for getting started with anything PyTorch or TensorFlow related. So at a low level, that's kind of how you can get your foot in the door with AI frameworks in an accessible manner. To the right, we move into different AI toolkits we have available. You'll see as we go through this presentation deck, NVIDIA offers a lot of different frameworks and SDKs. I'm going to introduce a lot of them, and all of them are available within the NGC catalog. I think it's really awesome. You guys are going to learn more about Clara in the upcoming weeks, something that is also available inside NGC. But here we have listed just a couple of key components as far as the ML and deep learning workflow and life goes. So we have the Tau Toolkit is the first thing listed here. So train, adapt, and optimize is the main focus of the Tau Toolkit. It allows you to be used in Jupyter notebooks and through the CLI also. I think in any case, when you're getting started with one of these frameworks, whether it be Tau or others, having the Jupyter notebooks accessible to you is definitely an easy way to get started. And that's included within these toolkits. And then for Tau specifically, it gives us the ability to fine-tune pre-trained AI models. And we'll talk a lot about having pre-trained AI models available to you within NGC, because I think that is really such an amazing resource for people who are just getting started with training their own networks, or people who are really well versed in it and are looking for ways to kind of get rid of some of that overhead of training from scratch. To the right after that, we have some models. So if you go through and actually just search BERT, for example, in the NGC catalog, it's actually almost a little overwhelming how many different applications and frameworks we have built around these models. You can do things like automatic speech recognition. Any model that I think is widely used is available to you on NGC and has a lot of well-defined work done around it as well. So kind of in company with those models, we have model scripts available. So like I said, I'm a big fan of having Jupyter notebooks available. You'll see with any of these frameworks, we have pretty comprehensive Jupyter notebooks that walk you through kind of the key components you'll need from all the toolkits and are really kind of your first step for getting up and going with whether it is BERT or whether it's Tau Toolkit or TensorRT. Any of those are a good option. And having a Jupyter notebook just makes it that much easier to actually be successful with using those tools. And then the last thing we have here are collections, and I'll talk about more collections later. I'm a huge fan of the collections. I think this is something really growing within NGC, and it just kind of offers a stack of things that are giving you kind of the full picture on one of our subject areas. So the one I like to focus on is we have an HPC collection, which can do anything from like molecular dynamics work to scientific visualization. It has introduction materials to that collection. It has all the containers you'll need, and it's just kind of a one-stop shop for different collections within NGC. So that kind of encompasses all the things that we have listed to the left. At the bottom, you'll see there's almost too many use cases to talk about, but you'll see there are just a couple categories of things that you can explore when you actually get onto NGC. A really cool thing I think that is, I want to make sure I highlight about NGC is that these models, all the work here is fine-tuned by people much smarter than me at NVIDIA and who have trained and done a lot of work to get these pre-trained models and all these materials really accessible to you. So having the ability to maybe try out your own conversational AI workload, but as pre-trained by a real professional in that area is a really unique opportunity to NGC. So another thing that I think is important to highlight for NGC is that we really are focusing on the whole workflow for AI end-to-end from the actual framework you're using through training and inference. All the software for those components is highlighted and usable from inside NGC. We have here below listed just kind of the different steps that you have. Like I said, we can go all the way from training your model, the optimizing and tuning that happens, and then we can go through inference within our NGC catalog. A couple key components, one of which I've already mentioned before is Tau. That's kind of your first step as far as reducing your training time, starting from a pre-trained model. Tau SDK is kind of your best one-stop shop for that. Moving to the right on the bottom there, we have TensorRT, which we've listed, which is our SDK for inference. The main thing we target when we're using TensorRT is the low latency and high throughput that we're looking for inference. It's really awesome because, like it says here, integrated with all major frameworks. So that means whether you're using PyTorch, Onyx, TensorFlow, or MATLAB, TensorRT is an option for something you can use on the CPU or the GPU. Really, wherever your workload is, TensorRT, I think, is one of the first steps you can take to really seeing a performance benefit on the inference side. And then on the last little bit here, we also have Triton. So lots of T's on this slide. Our Triton is our inference serving platform where you can go ahead and actually deploy, run, and scale your models. So when you're first getting into using NGC, at least for my experience, it was just more about getting models running and training and doing inference just for my own learning. And I think that NGC can certainly be used for that. But if you plan on taking this to a level where you want to actually deploy, Triton Inference Server is your best option there to go ahead and deploy your model. And this also works on any framework, which makes it really diverse and easy to use for whatever model you're interested in. So this at a high level is trying to emphasize that you can do end-to-end workflows within our NGC kind of framework. Taking even a step higher than that, we have further SDKs that really allow us to simplify or at least condense all the information or tools you'll need for big AI workloads. So here are just 4 main categories we have. Things that I think are every student is really interested in. I'm personally really interested in, and NVIDIA has put the resources and tools into actually creating an SDK around these areas. So Riva, we have on the left, is our speech AI applications. It's intended to be super customizable for your specific need and also real time, which makes it very cool. So all these SDKs are accessible within our NGC catalog. To the right, we move to DeepStream. So this is everything you would need for vision AI related workloads. You can do multi-sensor processing and image understanding. So anything intelligent video analytics related, DeepStream is your one-stop shop for that. Moving to the right, we have Merlin for our recommenders at scale. So I think this is this can become a really big project, and so this addresses some common within Merlin. We're able to address some common pre-processing techniques that are done for recommender systems, and it also has the ability to support massive amounts of data, which you would want to use to actually create your own recommender. And then to the right, we have NVIDIA Clara. So just kind of, I guess, a one-sentence preview of the information coming up, I think, in 2 weeks. Which allows us to do AI-powered imaging and genomics work. And it's our framework for development and deployment of smart medical sensors as well. So Clara is a pretty broad topic, with the highlight being, I guess, medical imaging. And I think you guys will get the opportunity to actually hear from one of NVIDIA's experts on that in the upcoming weeks, because I think that's a really great tool and also a really great collection within the NGC catalog as well. I did just want to have another little slide about NVIDIA Tau. I think this is one of our newer SDKs, and it really is, if for someone getting into the training world or for model training world and doesn't really know where to start, Tau gives you kind of the opportunity to work within a framework that's easy to understand and abstracts away some of the more confusing details about maybe a PyTorch or a TensorFlow. So you're able to get all the way to production ready models if you want to with the NVIDIA Tau SDK. You can train it anywhere. So we'll talk a little bit about deployment from NGC later, but that makes it very flexible. And like I said earlier, we're optimizing for deployment here and integrating with some of our other SDKs. So I think this is a nice slide to follow what we just had, because Tau really can mesh together some of the SDKs that we had shown earlier, like DeepStream for video analytics and Riva as well. So this just kind of shows how Tau almost becomes your one-stop shop for your first training things. All right, so let's talk a little bit about the actual containers we have. So when you go to the NGC catalog, I also think while I'm speaking, it wouldn't be a bad idea to just pull up this catalog and maybe take a look yourself. There's quite a lot of information there, as you'll see when you actually pull up the website yourself. But I do want to highlight some key things that we have here. It also is really nice that we have just heard from more information about different containers, especially Kubernetes, which is widely used within the NGC catalog itself. A main thing I want to highlight about our actual containers is just the diversity of workloads that we have. You saw already all the different purpose-built use cases we have, from intelligent video analytics, conversational AI, medical imaging. It really is a massive amount of different workloads that you can pursue. Anything that fits your interest, the NGC catalog has some sort of container to provide. Another key factor that we have going for us within NGC is that all the containers are optimized for performance and are extremely scalable. So these containers are updated on an almost monthly basis, making sure that you always are getting the latest features and the best performance. And you're even able to go all the way up to a multi-GPU or multi-node system if that's something that you're interested in doing, whether it be in your training or your inference workloads. One thing that I think is important also to notice is that these are pretty reliable and secure ways of actually running containers. They're tested out on not only local workstations and servers, but also in different cloud instances, which I think is the easiest way to get up and going with these NGC containers. And they're designed for all different types of runtimes, or whether you're an enterprise or HPC or research, you're able to use Docker, you could use Singularity and a bunch of other runtimes. So this is just adding to the overall flexibility that we see within the NGC catalog. So adding on to that, the run anywhere is, I think, really useful, especially if you're new to the deep learning or machine learning world. You might not just have tons of GPU resources available to you, but that doesn't mean you can't actually work with NGC. You can run on bare metal, you can run in VMs, you can run with Kubernetes. It's platform agnostic, so you can go ahead with x86 or ARM. It could be on any cloud, on-prem. It's really just any configuration you can imagine is an option for you to deploy. So I think that, at least for me, I always view that as a barrier to entry for these types of workloads, but I think NGC kind of evens the playing field in that regard. And I know we talked a little bit about pre-trained models at the very beginning, and I don't want to go through an in-depth explanation of some deep topic, but I do think that emphasizing the accessibility to pre-trained models within NGC is really important here. I know we talked about it a little bit with Tao, but mainly what I want to emphasize here is that using transfer learning, using these pre-trained models which are available within NGC, takes information we already have from one problem and applies it to some related area that you're interested in. So with those inner layers that we have that highlighted on the screen, those are the most compute intensive, and we're able to leverage them in transfer learning and actually cut down on the training time, which I think is the main benefit you see from using pre-trained models. And you also need way less data. We just heard about storage limitations before this, and using these pre-trained models and transfer learning techniques really offers you a way to do faster training and also have just less data needed to actually go ahead through this process. And then of course, this leads to higher accuracy, which is always the goal, is you inherit some of that performance accuracy from the pre-trained model itself, and you're able to apply it to your own problem. So this is something that I think we've really pushed at NVIDIA to get more people aware of, is these pre-trained models that you have available to you within NGC. So let's take a look at what kind of workloads you can actually use within the pre-trained models on NGC. So these are just a couple. The more, I think, might even be an understatement. There's absolutely so many things you can do with these pre-trained models. And I think that taking a look through some of them on NGC is your best way to actually get familiar with them. If you have a specific workload you're targeting and you're wondering if there's a model out there that you could actually use in a pre-trained sense, I think that's a really good place to actually get interested as well. A thing that we're going to talk about next is model resumes. I've emphasized a lot how much information there is on NGC. So we're taking steps within NVIDIA to try to make it easier to get the best pre-trained model, the best model for your use case, or maybe even find a collection that encompasses the work that you're most interested in. So model resumes show training configurations, performance metrics, and other useful information when you're trying to decide what pre-trained model best addresses your use case. So there's a couple of use cases here highlighted that we haven't talked about yet. So TTS, text to speech, is a cool one that I think there's a lot of work being done within NGC currently on that. And I think the main takeaway from this slide is the flexibility of pre-trained models. You can really, with the base that we've built for NGC, you can really take these pre-trained models in so many different directions, and you can take it all the way to a production level quality, and you can test out so many different pre-trained models that I think this is a really great place to get started if you're interested in doing your own training. All right. So I gave a little bit of a hint at a way to actually find the best pre-trained model to start with, but here's a deeper dive into what's a semi-new addition. And it is our model resumes is one of the main ways you can go ahead and actually get useful information about the pre-trained model to go ahead and pick it for your own solution. So this will tell you information about how the model was built, what the training data was, and even details as fine-grained as the network architecture. You're able to compare different models, how they're used, what limitations they have, and then you can even evaluate with your own data. So one thing that might not be extremely obvious from looking and talking about these pre-trained models available is how many options there are and how it can be actually extremely difficult sometimes to pick what pre-trained model is best for your use case. And so this is kind of our response to that. slight hiccup is that you're able to now do comparisons with pre-trained models, get step-by-step guides and examples on how you can build your custom models, and kind of do a comparison there. You can even see we have listed things like popularity, the domain, usage, what license you have to have, all of which I think are pretty useful when you're going through the process of trying to actually decide what pre-trained model is best for your use case. So if you're like me and you're overwhelmed by the options that you have available when you open up the NGC catalog, model resumes is a really great way to actually identify the right model for your use case much faster. I had a little bit of a demo. Let's see. I don't know if we need to go through it. I think that it's just a screen recording of the actual NGC catalog. You can see here we're actually looking at something to do with the Clara segmentation, and it's a model that we have within the NGC catalog. And here we just walk through the model resume and how it compares to other pre-trained models that exist in a similar kind of world. To the left, we have the same sort of description that we had previously, where you can see what the pre-trained model is good for. So maybe if you guys are more experienced in the medical world, this will make more sense to you than it does to me, but we have a model for volumetric segmentation on the spleen. So this seems like some good image processing that could be used for potential other Clara workloads. So next week, or in 2 weeks, you'll get a deeper dive into all the things available on Clara, but this little screenshot here is mainly to highlight how you can go through and compare different pre-trained workloads, pre-trained models, excuse me, and evaluate them best for your workload. And I will post, like I said it earlier, the slides will be posted. So if you're looking for a little video walkthrough, they'll be available here.
Introducing NGC catalog model resume.
Sorry about that. Okay. I'd really think we could drive this point home with just one more slide. I know you guys might be tired of hearing all the ways to pick your right pre-trained model faster, but I think it is really an important component and something really successful within NGC. To the left, we have two categories, which we haven't actually used to distinguish our models yet, but they're broken down into generalized models. So things like BERT, DLRM, kind of the big models that you see in things like MLPerf benchmarks. And then below you have purpose-built models, which I, as a person who doesn't come from an extremely deep learning background, think those are the easiest to get involved with. And then we've taken the time to actually, perfect and work and put in the effort to actually have those perfect purpose-built models for you to use as your pre-trained model. So if the problem that you're working on is specific to a domain and you're not sure what framework best fits it, then I think that purpose-built models are certainly a good option to get involved with. Like we had already covered model resumes, and I think that an important distinction to have here is when to use a purpose-built model versus when to use simply a generalized model. So that's an important distinction to have here. You can evaluate these models with your own data, and you don't need to download or install anything to do that. And you can experiment with them within our SDKs as well. So the opportunity to experiment with your data on a pre-trained model is just kind of endless here in NGC. So that's kind of the emphasis I wanted to make there on picking a pre-trained model. And we've talked a little bit, but not much yet, about deployment for these options, which might be a question that you guys have as well. Recently announced is the one-click deploy for Google Cloud. I think this is a game changer for me. I actually was just testing it out this morning, and this screenshot is true to what it actually looks like. You're able to, with one click, and I'm sure at some cost, do deployment to Google Cloud. In this case, we're looking at a Tau Toolkit computer vision sample workflow. And it takes what used to be 11 plus steps and really turns it into one click to get it on Jupyter Lab. And so I think the main focus that I want to emphasize here is that NGC kind of removes some barriers to entry that are typical for getting started with data science and machine learning. One of which is always like the setup, actually running containers. That can be extremely difficult sometimes, especially if you're new to it. And so having this one-click deployment to a cloud service provider is really awesome. I think that's a great improvement in NGC. There are over 200 Jupyter Network examples, which is overwhelming, but awesome. They cover things like conversational AI, where you actually get to do some speaking and some interacting, computer vision, and many, many more. So I think a next step after this talk would be to actually dive into some of those Jupyter notebooks, see what you can get running, experience some of those SDKs in a really easy manner. And then the last thing, so I had mentioned earlier that I'm a huge fan of the collection section at NGC. It's something that I think is growing and something that I think helps people who are newer to maybe the container environment or maybe new to the deep learning, data science, machine learning community, because it gives you background information. It gives you all the assets that you need together, and it removes any kind of additional guesswork that you have to put in, whether you're trying to install your own dependencies, anything that kind of comes with the territory of working with your own specialized container. The collections tried to get rid of any of that gray area. So you're able to, there's a whole collection section on the NGC catalog. It'll walk you through everything you need to get started. You can fine tune, deploy your own models, deploy your container and start up a Jupyter Notebook instance. All of that happens and all of that instruction is in one location. And I had mentioned earlier the HPC collection, but there are so many there. And I think the number keeps growing. One of which I noticed earlier that was new to me, at least, is Maxine has its own collection there for virtual collaboration and content creation applications like video conferencing and live streaming, which is another one of our SDKs at NVIDIA, that in a collection, you get the opportunity to kind of explore all the different elements and get not a handhold, but a good tutorial through how to use them. And I think that's a really good place to get your toes wet on interacting with NGC. And I know we're running up against the hour, so I will be quick on these last two slides. I think we already got a lot of good information about Kubernetes and even a little bit of an introduction to Helm charts as well. That is something that NGC keeps in mind. It focuses on consistent deployment across platforms to make sure that it's easy to adopt on many different computing strategies. If you want to pursue scaling out from NGC, we have Kubernetes available to do that auto scaling to fit your demand and try to optimize cost while doing so. Helm, which from my understanding is an application package manager, on top of Kubernetes, allows you to deploy multiple different containers and configure the security and resources with single commands. So that's a good way. We have a whole Helm chart section within NGC that allows you to get started with that usage. The Helm chart registry, that's what it's called, which allows you to deploy drivers, runtimes, device plugins, and monitoring tools all within NGC. So I know we really brushed over this, but this is just another aspect of NGC that takes more of a cloud approach and allows you to do consistent deployments wherever that may be for you. The last thing, which is just kind of a summary slide, is just, I guess, a note to get out there and get started on your own with NGC. As much as I want to sit and talk about it all day and all the cool resources we have available to you, the best place to really learn with it is just to go and try it yourself. We have tons of technical blogs and webinars. Our last GTC just wrapped up last week. There was a ton of information there about new SDKs as well. So I would really just urge you to go explore the catalog, see what fits your interests, and get your hands dirty on your own. And I hope you guys are looking forward to learning more about Claire in the upcoming weeks. I really appreciate you having me here today and hope you guys learned a little bit something about NGC.
Wow, thank you so much. Really, really appreciate it. Like I said, put the series link in the chat itself. I know we're up against the hour, so we'll go ahead and wrap it up. But feel free to log on there. We'll post the replay in the next couple of days of this session. I know there's some questions about that. And then, like I said, feel free to sign up for the next session. We'll continue to add sessions as we go, sort of on an ongoing basis. We've gone through the first 5. You guys have been phenomenal as far as asking questions and engaging. I think, honestly, we've run a lot of these series, and in my opinion, this is probably the most engaged audience I've seen so far. So love the momentum that's going on with the AI Hub and between Clemson and MUSC. So with that, appreciate everyone's time. If you guys got questions, feel free to reach out to us directly, reply back, or contact the awesome folks at the AI Hub as well. Thank you, guys. Have a great day.